out which regression and get the equation for it, and then try solving this. Doesn't matter which way. Okay?
Gotcha. We're lucky to math that.
Thank you, George.
You know, it's always tricky because I think that went on a little longer than necessary. Snag a calculator, Robbie.
What?
I said snag a calculator, do them real quick, real quick.
Snag one?
And there's two right there.
I thought you actually snag mine. I was like, somebody already did.
Oh, I'm sorry.
I know where to go.
We're also getting a couple more calculators to do last minute.
Oh, yes.
If not, we have spares. We're waiting on a couple more. But in the meantime, just as a review to test your skills, so we can find out where you are, get ready to do stuff. We're using this on the calculator, finding regressions, find out which regression you find the equation for it, and then try solving this for x, of course. And it doesn't really matter which way you do it. It's up to you. Okay? We'll give you, I don't know, 5 or 15? About 3 minutes. You guys need a calculator or you got one?
Is that one being used?
If you guys can't see over there, just you can accommodate.
Is that an x plus 3 on the bottom term?
At the very top one, the bottom term all the way to the right, the
Yes.
denominator?
Yeah.
Yeah. So half of them.
So you found my threes.
That's okay. Better than my 4s and 5s.
I've noticed that.
Yeah, I use a scope.
It's right here. And I'm, what, here somewhere.
Pizza? I had to grab a muffin from my lap. Sorry.
Thank you.
Sure. There's my husband.
There's one.
Wow.
Steve. Actually, if you use my 84,
Oh, that's so cute.
I'll use the 83. I know what I'm doing, so. I'm a pro.
So, we're graphing that, finding the regression of that, and we're solving by any means that you know. I'll give you guys a couple more minutes, and we'll just throw up the answers for you and see how you did.
You don't grab them, just know where you're like,
We purposely did that first one to get you on the parentheses.
yeah.
I know, that's what I thought. I was
Double
like,
up. I guess I triple up. Add more parentheses.
That's one thing I learned in high school. We can never have too many parentheses.
Easy to have too few.
It's easy to have too few of them, but you can never have too many.
So it's 4 or 9, right? On the bottom, right?
Yeah, that's a 4.
That's a 4.
Now you can know my fours. Oh, now it's a 4 or 1.
I purposely flipped the coin okay. Okay.
Yeah, I know.
So
Wait, is that a 3 or a 1? I thought that was a, no, the back.
that's
That's 4, is that a 3? It looks like a 1.
a 3.
Okay, could you make it?
I wrote that too small.
Okay.
Oh.
I'm gonna actually pop it up. So we got it to look like. So did you guys get something like that?
Hold up. I'll get something like that, you know.
I definitely missed something.
So, for the sake of time, so we graphed that thing, and as you may notice, or have found out, trying to graph this right here is not easy with the conventional methods. Notice up here though, we actually have something new. Okay? So, let's start off with that. Now, I want to throw off a couple disclaimers. I'm actually going to hand these out now. Couple disclaimers. There will probably be things that you might not understand in here, probably because of you level up math. Okay, we're going from basic math techniques all the way up to say calculus techniques. So if there's something you don't understand, that's probably why. Okay. The other thing in this, for people here that are using 83s or want to use things for the 83 on this. Not everything in this presentation is going to work for a TI-84. It will work for the TI-84. We will tell you what works and what doesn't. But if you look through, does everybody have a handout? I think I forgot to give you one. Okay, so with that, so how'd you guys do on the graphing? Pretty good? Good? Iffy? That's okay. We'll get you like perfectly set up on this, okay? So.
The first thing we want to show you is the new math print updates and what that brings to the calculator. If you look if you have the update and you look in the math section here, there are some new functions that have been added to this. Some of the notable and very useful ones. Hey, I can use keyboard for this. Are things like the log base function, which allows you to put in a log to any base just by punching in the base here. So if we wanted to take the log base 3 of 5 before, you would have had to actually punch in the log of 5 divided by the log of 3 to change the base formula. Now they got a function that just handles it for you. But you do have to note that you put in the number here. If we were to try to log base 3 of 5, we just punched in 3, 5 there. It's all in the base. You do have to remember when you're using this that after you punch that in, you have to use the arrow key, move yourself off of that, punch the number, and we get 1.46497. Another function they've added on here that's very useful is under math, and then you go to the numbers. There's the num section. Absolute value bars. From here, you can punch in whatever equation you want, and it'll graph the absolute value, and the value of it, or give you the absolute value to just run it off that. So I'm going to. That's not what I'm going to do. I'm going to turn off this graph for the moment. And then if I go in through the math, punch in the absolute value here, and put in, say, the absolute value of x plus 5.
And this may seem like a little given, but say you have an absolute value. What if I was that evil person to put an absolute value in here as well, where you have to keep track of the absolute values, parentheses as well. This will actually help simplify it up by actually showing the absolute value bars. So we're showing a bunch of ways to help get rid of all of those parentheses and get rid of a lot of those parentheses errors.
Primarily, it makes it look cleaner, but that makes a huge difference when you're punching in a lot of terms and have to keep track of everything. So if I were to graph this right now, it shows perfect absolute value graph, and when you see it in here, it looks exactly like it would if you were to actually write it out on the page. Then the next one here is really useful for this equation here, and that's how we did what we did here under math. That's straight down, isn't it?
Yeah.
This isn't how I usually get to them, so.
Yeah.
If you go up, it'll take you to the bottom. Yeah, go up, it'll take you to the bottom.
Yeah, it wasn't in the first the first group there. Oh, here we are.
Okay.
Down under the math number, down at D here, we've got our fraction bar, which inserts a little bar there so you can enter your expression on top and your expression on the bottom.
You'll use the arrow keys to navigate between the top and bottom to get in and out of the fraction. But as you can see, had we shown you that at the start, this would have been no problem. You would have only had to use the parentheses where we would actually write them down. But you can try putting in this original one again with the fraction bar, and I guarantee it will be 50 times easier, and you will not have the fraction bar mistakes, or parentheses mistakes. This is really helpful, especially when showing classes maybe a pre-calc course, when they're trying to graph an equation, and there's just people that are having a really tough time with the parentheses. This is really, really, really helpful. So that way, it helps simplify it down for them a bit. But, so you can try regraphing that.
The next thing we're going to look at is some of the tricks that you can use from the regression menu. This also, if you have a math preliminary print update, it changes how this looks a little bit.
A lot of students will panic when we go to update their calculator and be like, oh, what's up in my regression menu? What happened?
Well, it's just as easy to use as before. It's just it looks very different, and there are a couple things they've added in that are very useful features. If I were to punch in the same regression we've got there, 3, 7, 8, and then over here it was 5, 7, 11, 12.
You guys all saw the, or you guys all have the newer version as far as I know. So, that one's
The
not
pink one
on.
might not be.
Okay.
Sorry.
You have two people next to you. So you can, the older version, it doesn't have this menu, it doesn't have a menu for it. So, you'd have to know what goes where for the actual input for it. With the new update, there's an actual menu for it, so you know what they're asking for and what all you can ask them for.
So if we went from here to the stat, calc, linear regression as usual.
Oh, which one?
I did? Okay, well.
Yeah, the computer's a little slow.
Yeah, I'm noticing that this emulator is far from perfect. So I'm going to go back in here, stat, calc. What?
Hang on. Calc goes 4.
Oh, what is it?
Okay. But
Well, this one has already built into it. It has it set up here L1 and L2. So if I wanted to modify what lists I was using, the option's already here. We no longer have to put in L1, comma, L2, comma, then wherever we're going to store it. Down here, we have, right here it says store around in the reg queue. So that's where it's going to store the regression equation. So if we went from here to vars, y vars, function, and then just threw on y1.
and all those y bars, the function y1 through y0, those are referring to your y equals right here. So
No, so from here, if I hit calculate, it'll calculate the regression and store it straight into y1. So it's already in there, ready to be graphed. One of the most useful things about this feature here, though, is if you ever have a problem, which I know we always end up running into at some point or another, where they give us one set of years and then two different equations that we're supposed to get with the points for, you know, say women's times and men's times in the track meet or whatever, we have to come up with an regression for each. Well, you can punch in the years in list 1. That's always your x. You know, up here is always your x. And then punch in the data points for one equation into list 2, data points for the other equation into list 3. So then when we get the regression for the 1, all we have to do is right here, switch this over to list 2, second, and to list 3, second, 3, now it's taking the next set of points. And over here, switch this to y2. Now, I'm not going to do that in this case because I only have points in the two lists. If I tell it to take from a list that there's no points in, it'll freak out and tell me you can't do that. And
This is helpful because compared to the old 83, a lot of students didn't know that it assumed list 1 and list 2. So after they did 1, they would erase the list and then do list 2. Whereas with this, you can put in all 3 lists at the same time and just pull L1, L2 for one equation and L1, L3 for your other equation without actually having to erase anything.
you can do that on the 83, and you can do that with the TI-84 without the math print update, but it just requires a little more typing. What you would do is you would put in, you would hit the equation, it would just say, you know, lin reg, and then what you would put in is L1 for your x, and then comma, whatever list you're using for your y, and then comma, whatever variable you wanted it to store into. So you could do it, but this one just makes it nicer.
Pretty much all your input from this that you just put in, you just put that in the older version, commas, but not a lot of students would know that, just because it just said linear regression.
I messed up, how did you get your Y1?
Oh, that was,
Under bars.
we're going to show you a quicker way to get to that in a second, but what we went to was bars, y bars, function, y1.
Wow, beautiful, thank you.
What's there? So then all you have to do to get it to actually calculate this out, hit calculate, and now if we go to y equals, there it is.
The 1x plus 4, which is what we had over here.
Yep.
Any questions on any of that before we hop in further? Okay.
Alright, so you got x1 and x2. Next function we wanted to show here is the, also under math we have down here, we have the x root and the root of whatever. This also was in there before, but in a slightly different form. This way it actually puts it where you expect it to be. So if we have, say, the 5th root of 32. That's not what I put in here because I don't like this emulator at all. Oh, come on. Thank you. Thank you. You can see exactly where that 5 is. So if we had, say, 7 times the 5th root of 32, you're not as likely to make the mistake of putting in 7, you know, the 75th root of 32, because before what they had was they just had the number out in front of it, and there was no way of being able to tell for sure that that was actually supposed to be on the root.
You can do any root. You can even do, like if you're trying to graph, for some odd reason they want you to have the x root. When you do exponents now, it'll actually raise it for you. You'll just arrow key out of that. You'll always want, a lot of people, what they're not used to is that they have to arrow key out of square roots now. And so they'll have the entire thing under a root when they didn't want it to. So navigating with the arrow key is a lot more needed now.
Yeah, you do have to use the arrow to get to where you're going onto this root. And then if we were to graph something like the 5th root of x to the power of 3x plus 5.
Now I only put the parentheses up there to show that it's in the exponent.
But as you can see, you don't actually need the parentheses even here. But you do have to remember, if I was gonna run a different equation where it was like x to the power of 3x, and then after that we have plus 5. Well, if you punch in the plus 5 while you're still up here, this is what it's going to give you. So you do have to remember, if you want to throw on something, some calculation after that, you have to step out of the exponent, but this way you don't have to actually put any parentheses around it. And then you also have to step out of the square root there. So you do have to pay some attention, make sure you're using your arrow keys. But this does make things look a lot cleaner.
Okay, so can I just get a show of raise of hands? Who here is familiar with calculus? We got 2. Okay, 3. Sorry. So I'm sure you guys already know that you can't do indefinite derivatives and integrals on a calculator. They have to be numerically calculated. So, and trying to plug that in the old way, the input for it, trying to memorize the input for it was always a pain. So with the new 84 update, they changed it around a bit, okay? So we'll go under the math, and I'm just gonna hit the arrow key to get to the bottom, and you'll see, we will start with showing integrals, okay? At number 9, it'll show fn int. Now on an old calculator, it'd just say fn int, parentheses, and you'd have to know what to do from there. On here, if you're familiar with calculus, that's a good friend of yours. That looks familiar. Whereas we would put our lower bound and our upper bound, and I don't know, 3x plus 5. And then arrow key over, dx, integrate in terms of x, and then it'll calculate it. Not a lot of people know the input for it, what comes after what, especially if they're trying to learn it by themselves. Okay? The same works for derivatives. And derived is number 8. If we go to that, that looks familiar too. D, I'm just going to use x, d dx. You can use any as long as you derive in respect to it. So that same equation, 3x plus 5, x is equal to whatever you want to find the
We
derivative.
have 3 plus 5 there.
Oops,
That's going to be 0.
plus 5, okay. So we want to end 5 maybe. There we go. That's the slope of it, of this linear equation at 5. Well, it doesn't change too much. Okay? And then one more, I won't get too far into it, but we have summations here as well. So if you're familiar with summations, I've seen it on the 83 once before, and I had no clue how to plug it in. So on here, it's actually really nice. If you're familiar with how to, or what to do with a summation, that looks just like it. Okay? So, any questions on any of that stuff? No? Okay.
So by now, we've thrown a lot of new functions at you. If you weren't already familiar with them and you're not writing them down, then there's a good chance you could pretty easily have forgotten, even by now, where some of them are. So, quick way to access them, if you hit alpha, and then any of these 4 buttons.
The top 4, not the graph though.
Yeah, not the graph. The graph doesn't do anything when you hit alpha now. A lot of these functions are stored right here. This one shows the fraction bar, which I can then put in whatever I want here. 6 and 2, we'll say. And of course, it gives me 3.
These are called the alpha hotkeys, or at least that's what I call them.
Yeah.
I haven't seen anyone else assign a name to them yet.
Technically, they're the alpha function keys, but
Close enough.
so. And then down here we have some of the other fraction functions that we didn't show. This one, for example, would convert a mixed number to improper. So yeah, this is not showing, say, 4 times 3 over 2. If I punch that in there, this is an actual mixed number, and it'll give you 11 halves. So quicker way to run that. Over on the second hotkey here, we have our absolute value at the top. The summation notation, the m derived, the integral, and the log base. So you can quickly get to those anytime you want. Next hotkey over. I guess I actually have to hit something before the last one. Come on.
Oh,
It's frozen.
no.
No, we're good. We're good, I think. Here we have our matrices, which I am not familiar with matrices on the Allen calculator. I'm sure he can tell you all about them though.
So, for those of you who are familiar with matrices, I know that a lot of people, when you get a system of linear equations, you know how you had to use the substitution method or elimination method to solve for them? You can actually use a matrix to solve,
Matrix.
matrix. You can use a matrix to solve it for you. Actually find out each variable for it. And before, you would actually have to go into your matrix button. It's different on the 83. You'd have to go into your matrix button, and it was always a pain because you had to X out and all that stuff. Well, now you can actually make an on-the-spot matrix. Before there was a menu for it, but now you can actually do it right on the main screen. So say we had, I'm just going to write it down for you guys. So say we had x plus 2y minus 3z is equal to 5. We get minus 2y plus 2z is equal to 3. Negative 2x plus y plus 2z is equal to negative 5. Now, I know that usually what you'll be working with is only 2 variables and 2 equations. But once you get into maybe 5 variables, 5 equations, and so on, the substitution or elimination gets really, really, really messy. Well, what you can do with a matrix is close. I'm gonna hammer it in the middle. We'll make a matrix right on the spot. Okay.
Matrix.
Okay. I'm having oodles of fun right now. 4 columns and 3 rows. Okay. So now we have all these zeros. Okay. What we do is we'll set all of one variable in one column, all of another variable in the second column, all of the third variable in the third column. But we also want to make sure it's equal to 0. So we need to move the 5, 3, and negative 5 over. So this will become negative 5, negative 3, positive 5. Equals 0. Okay? Any questions on that? So now, we're going to take the constants in front of each number, or in front of each variable and pull it over, okay? So, 1, 2, oh, man.
You did it wrong.
You don't
It's-
press enter, you just go over it.
Yes.
Yeah, you navigate to your keys.
No, I don't want, no, stop it. Stop it.
See, now, I told you, the simulator is not perfect.
It's, I don't want 0.3 times that.
Go over and
1,
press
2, negative 3, negative 5.
Actually, I think that's subtraction 5. I think you need to go back up. I don't think it won't do the negative with the subtraction button on the keyboard. You
Oh.
actually have to do it by
Right,
clicking.
I forgot.
That's okay.
I don't know where the.
I know the emulator better,
Yeah.
so there you go.
I would love to reprogram the hotkeys on this.
Oh, yeah.
TI has decided that they don't want to devote much more time to the emulator, so they don't update it.
Yeah,
Well, at least
and
they're
it
nice.
shows.
At least they're nice enough to give us,
Something?
yeah, like at least they're nice enough to give the latest update for the emulator.
I have a friend who's got an emulator who's tablet.
Also in the top left-hand corner, it's negative 3, not negative 5.
Oh, yeah, that's negative 5 here.
Man, I'm dyslexic. That's top right.
Isn't that what I said?
You said top left, I think. Okay, anywho, so I'm gonna go to Major C.
Wait.
I'm not hitting backspace, or I'm not hitting backspace.
I discovered only today that is clear.
So under the second matrix button, the second inverse x, you'll have your matrices. We're going to go to math. Scroll down to, it's called RRDF.
And I'd be willing to bet we're going to get a syntax error.
Wouldn't surprise me. Now, the notice how the ones are in a diagonal. That means you did good. Okay. That's what it exactly for. The numbers on the right are your x, y, and z solved for. Okay. So that's helpful for really big ones. Okay. It might be quicker to do like two variable ones, but so that's how you work the matrices on that.
Next portion of that.
Yep, that's the matrices.
And then the last thing we want to show you with these help function keys over here. These are your y bars, 1 through 10.
Yep.
If you want to store any equation into one of those lines, you hit alpha, trace, and you can just pick one.
Yep, so instead of going to your bars, like y bars, function, all that stuff, you can just pop it right up on your function. So that thing's actually really helpful because it has a lot of things from a lot of different areas all put together. Okay, so the next thing, how many of you are familiar with stat? Like, not just statistics, but like the putting in data in lists and stuff like that. Pretty good? Okay. So we showed you how to store data. We showed you how to store a function. Did you know though, say, we have something in L1, right? Yep. Okay. So, real quick, say we have 3x plus 5, okay? y1 is assigned to that, okay? If I were to do alpha, y1, and pop it up on the main screen, what you can do is you can put a parenthesis after it, put a number, it'll actually evaluate it at that point, okay? So if I hit enter, it'll go to my y1, it'll plug in 2, and give me that answer for it. So instead of going to maybe a table, you can use this, okay? Now, you may think, well, Brian, what if I want to do a bunch of numbers and I'm lazy? You can use that same trick. If we go second parenthesis to pop up the brackets, I did my word wrong. It's got to be parenthesis, then bracket, and then put in maybe 2 numbers, close it. It'll spit 2 numbers back. That means it plugged in both of them. You're like, okay, well, what if I want to keep track of those numbers that I'm plugging in? Have no fear.
I'm terrified.
Remember how we had our L1 buttons on our numbers using the second? Well, all L1 is just a list of numbers, okay? So if I tell Y1 to plug evaluate itself at L1, it'll actually give me all the numbers. It'll plug in each number in L1. Now we're not done yet. Okay, we got one more thing to add to it. We showed you guys how to store things, right? So I'm going to copy that. Hit the, right above the on key, there's an arrow key called the store button. I'm going to save it to, I'm rewriting L2, but what that means is it's going to take all those answers and store in L2. So it'll give me the same thing, but now in my stat menu, those are all the answers that you just got. You can actually do mass data input using lists, okay? Now, for the sake of time, let's put it all together, okay? So, when I was tutoring, a couple things came to mind. I was helping a student with factoring. Actually, my teacher showed me this one, but after I'll show you. A teacher, we were factoring quadratic, okay? This does not erase. What's that equation again? I know I just erased it, but.
Which equation is quadratic?
Yeah.
Oh.
Negative 3x squared minus 2x plus 5. Now, my professor, she showed me, instead of trying to, we know that we're trying to find two numbers that multiply to be a times c and add to be b, okay? There's an actual way to do it on your calculator, okay? So, now this method is really cool for this, okay? So, I'm going to go to my y equals. I'm going to put my a times c value, whatever that value is, so in this case, negative 15, and divide it. Negative. I should really make that universal.
Yeah.
Divided by x, okay? So now what this means is, it's going, when we look in our table, it's going to start plugging in numbers for x, dividing into 15. So what happens if x divides evenly into 15? What do you think that means? We get a whole number, which means it's a factor, okay? But we also want this end term to also be able to add with x to be our b value. So we're going to take negative 15 divided by x and add x to it, okay? So now what this is going to do when we look under our table, of course, 0 is an error. In our y1, we're going to be looking for whole numbers, okay? Positive or negative. We know that 4 and negative 5 factors, wait, did I plug something wrong?
It's just 3 and negative 5.
It's negative
Oh,
5, 2.
Oh! Okay, so, I'm height challenged, I guess. So, negative, okay, that looks right. Okay, so negative 3, or negative 5 and 3 are factors, okay? So now over here, in this y2, it's going to tell us what it adds to, those two numbers add to. So what do you think that means? We know that our first list is, can help, or our first two lists help us find the factors of them, and the second one